Oh, first of all, thanks to organizer to the opportunity to make this report. Title of my report is Open Science in Ukraine, Open Cloud Mathematics. First of all, the relation between science and mathematics. In national and technical sciences, the main part of scientific work is mathematical calculations. It's clear. The mathematical tools available to the researcher are a very important factor affecting the productivity of his scientific work. Today, commercial products are used. What is it? Maplesoft, Mathematica, Wolfram.com, and others. They are used in many universities and scientific organizations. The creation and development of convenient mathematical tools is the most important task to be addressed by the management of the European Open Science Project. I demonstrate this my talk using our service, the Maspar Ukmaydua. You can see I open the site Maspar Ukmaydua and demonstrate my slides here. Second slide has a title Computer Algebra Systems. Several words about the history. The analytic language for the Mir-1 computer was developed in Kyiv at the Institute of Cybernetics under the leadership of the Viktor Mikhailovich Glushkov. It was in 1935. It was the first system of computer algebra in the world. Another package of the computer algebra was developed in Kyiv by his student Alexander Adolfovich Litichevsky. At the same time, computer algebra began to develop at the Lviv and Kyiv universities, at the Institute of Applied Problems of Mechanics and Mathematics. The algorithm developed at that time formed the basis of the MathPartner package. Today, this cloud mathematics project is being developed at the computer science department of our university. The project platform is deployed in the server of our faculty. You can see the address here. The address is http maspar ukmaydua. MathPartner Cloud Mathematics, several features. You can it is a new generation of computer algebra mathematics systems. The user language is as close as possible to the usual mathematical notations. Its original form is a certain dialect of the LaTeX. It is easily accepted by the school children and students. It is used in the educational process at our university, at Kyiv Academic University, and at the National University of Life and Environmental Sciences. Now I try to demonstrate several examples of this. And now we at the same point. We have now at our server, you can see the cloud system. This is first example of what we do. We want to make plots of three curves. First is arctangents, second is line minus x plus 1, and third is line 3x plus 5. You can see here. Now I demonstrate that you can do many interesting things. For example, you can do more, not 3 points, but 6 points in each line. Moreover, I want to do a movie, how it is. I can put here 40 slides. The variable t. Let's put the variable t, for example, here. 3t parameter t multiplied by x. T is a parameter. Let's try to make a picture. Now I put here once more thickness, and I put here 40 slides, sorry, for example 40 slides, and then I put the parameter t run from 0 to 1, yes, and then I make plot. Oh, sorry, not yes, plot, it will be good, but something not good. Here I try to do it's once more. Something has happened. Yes, it is not T, it is E. It was mistake. Now I change it to the another. It was not English. It was Ukrainian style. So once more I do it. More quickly, I put it here. It is 3tx. T is a variable, and I want to obtain 40 slides. Okay, you can see now plot. Oh yes, you can see it's a little movie. You can do it once more and to see what has happened when the variable t runs from 0 to 1. Okay, our next example, it is the possibility to obtain the table plots. This is table plots. This is x, this is y. We want to obtain a table, then approximate this table by the polynomial of the degree 4. You can see here the 4. Then we put the plot of the polynomial, plot of this table function in one picture. And you can see this, we obtain the polynomial in the symbolic form, and this curve, why it is, because you have here the function. Please show plots P and T. What is P and T? T is table plots, and P is plot of the polynomial P. Okay, next example I prepare for you. This is such complicated surfaces. What the surfaces? This is polynomial of with 3 variables. This is implicit plot. What is implicit plot? When this function is equal 0, then you obtain the surfaces, and this you can see such plots. You can do it less and bigger, and so on and so on. Another example is 3 surfaces. Now we build 3 surfaces, but this is a very big, very big steps, because the steps is it is possibilities to obtain the integrals. This is integral of such functions, and this is the result. Another examples is another integrals. And after integration, we obtain the derivative. You can see that the initial functions we obtain after the integration and differentiation, we obtain the same function that it was the first function. Logarithm of x in the power 1/2, we obtain once more. What this example? Once more, integration, differentiation. Another examples, what this is possibility to solve algebraic equation of the 3rd degree. You can see the 3 roots of these functions. Another example, we can solve the system of inequalities You have three inequalities, 1, 2, 3, and we obtain the interval where these three inequalities would be true, and this is answer. It is open interval between -1 and plus half. What this is, we can do expand. It is a function, logarithm of x in the power 2 multiplied by 4x, and after expand we obtain the result logarithm of 4 plus 3 multiplied by logarithm of x. It is true. This is another example of factor. You have such function. After factorization this function we obtain so little expression as subtract of two logarithms. I'm sorry. What this is another factorization. You have function where you can see several functions, sinus and cosinus, and it's multiplied. After the factorization, we obtain just one function, sinus from 1/3 of x. And what this example that we can do operation with subsets. My time is very quickly go to the end. This is an example for calculation of Grobner basis. If you have several polynomials, it was well known for all mathematicians who work in this field. That's very important some structure as Grobner basis, and we can compute it. One of the very difficult problem in computer algebra. Now we can reduce one polynomial with respect to the known Grobner basis from which generated by these two polynomials. This is the answer. What is this? It is just greatest common divisor of two polynomials. It's equal x. This is you have a matrix. You have one vectors. You want to solve system of linear equations, and this is answer. This is inverse matrix of M. This is, what is it? You have a matrix. You want to do LU decomposition, but not the clear LU. It's most complicated. You obtain LSU. What is S? S is diagonal matrix. And even if the matrix A is not regular, the determinant is equal 0, you can obtain such decomposition. It is the multiplication of LSU equal A. You can see here it is LSU multiplication to obtain A1. A1 you can see here. It's the same as it was matrix A here. And this is decomposition. This is, my time is about about the end. So the conclusion of my talk. Math Partner Open Cloud Mathematical Platform is a ready-made universal mathematical tool that can already be connected as a service to the European Union Open Science Platform. We proposed to the leadership of the European Union Open Science Project to create an international laboratory of the basis of our university, and the task of the laboratory will be to support and to develop Math Partner platform. Thank you for your attention. Maybe you have questions, please.